All right, welcome everyone. Welcome back to another episode of the LlamaIndex webinar series. This is Jerry here, and today we're super excited to be talking about production retrieval augmented generation. And this is the first time that we're actually doing a panel. And so this will be a panel with Tuana from Haystack, Max from sid.ai, as well as Bob from Weaviate. And so as mentioned, we'll start off with some brief presentations from each of the folks, around 5 minutes or so, just to kind of like give an overview of the respective companies as well as some basic concepts, and then we'll jump into the panel discussion. So let's go from there. Tuana, do you wanna kick us off?
Sure. Let me hopefully share my screen successfully. And hopefully you're seeing this, yes? Okay. So as we have 5 minutes, just a fair warning to everyone, these are very, very basic slides about my experiences with retrieval augmented generation and some things that I think are some interesting discussions that we can maybe have in the panel discussion. So quickly about myself, I'm Tuana. I'm one of the developer advocates at DeepSet, but I mainly focus on our open source LLM framework called Haystack. And obviously with that comes building a lot of RAG pipelines and some experiences dealing with large language models. So without further ado, I think I'm just going to start off by talking about why we even discuss RAG, what RAG is, what retrieval augmentation really achieves for us, so that if there's anyone who doesn't know, we just briefly go over it. So I boiled it down to 3 very basic bullet points. The models that we use currently use large language models are trained up to a certain point. So they don't really have information after that certain point. They also don't have any information on our confidential data. So RAG is just a methodology we use to help large language models get the relevant context to answer any query. And I love to show a very simple example. I reuse this example very frequently, but I think it depicts it quite well. So I use the example of this webinar this evening, well, evening for me. And I just put in this question in ChatGPT just a few hours ago, and I asked, who are the speakers at the LlamaIndex panel tonight? And as this is ChatGPT and it's actually quite a performant model, I got a pretty nice response admitting that it just doesn't know. So what we mean by retrieval augmented generation, or RAG, is basically a technique that allows us to transform this instruction to something like this. So instead of just inputting the query as is, we instruct the model to answer the query based on the provided context in this case, but obviously this could be a plethora of instructions, which is why I think RAG is actually quite exciting. And then we provide it with some relevant context before we ask the same question again. And the important part here is how we fill in this context. So I cheated and I just copy pasted off of your event page today. But what a RAG architecture achieves is to find the relevant context and instruct the model that we choose to use with that relevant context. So that looks a bit like this from a very, very high level. You might have external data. That could be your vector database like Weaviate. It could even be the web. And we have something we call a retriever component that acts as a sort of filter that can go through that external data source and select the most relevant context for any given question. And then we inject that into a prompt, which we then send to a large language model. And in my view today, what could be interesting to discuss is actually some of these things here. So some important building blocks from my experiences to build a RAG pipeline for production is the retrieving of the relevant documents, or the context. And we can do this in various ways. We can do that with keyword retrieval, embedding retrieval, or even hybrid retrieval. We can also play around with the ordering of the retrieved documents. And then, of course, the important things are the large language model we use and the actual prompt itself. I'm really going to focus on the top parts, but what they contribute to the quality of the RAG pipeline at the end is largely the quality of the context provided to the large language model If we don't provide it with the right context, then the large language model doesn't really have much to do. And then the last two is, given the context, the manner with which the large language model ends up transforming that into some sort of answer. So the first step, retrieval, we can, I think, probably discuss keyword retrieval and embedding retrieval and hybrid retrieval. Each have their own strengths and each have their reasons why you would pick it for a production use case or not. And especially because I think it's interesting to discuss hybrid retrieval. It has positives and negatives, but embedding retrievers or semantic search isn't great at necessarily retrieving anything that might require us to do some keyword-based search. And I think we can already think of some examples here. If you have like product IDs you want to search up, if you have an e-commerce platform or something like that, or company names that you have to look up. Embedding retrieval might not be great at this, but you still might need semantic search to happen. So in this case, you might need to look into combining two retrieval methodologies. And then this is the thing that I'm most excited about these days is re-ranking. And this is an effective way to retrieve a diverse set of documents. And this is quite new. It can help us combine multiple resources. And this is just going to be a brief intro in this slide deck, but it can help with lost in the middle. I'm going to show a paper that just came out quite recently about that. But quickly about diversity. So one thing that we're seeing that can be a problem in certain production applications of RAG pipelines is, imagine a similarity ranker. And here I've basically ordered documents and they're all in a color palette. So imagine the blue ones, they're all kind of different colors. They are different documents, but they are quite similar to each other. And if I'm ending up using a large language model whose context window only allows me to have this many documents, then I maybe have a problem, because in cases where I want to potentially answer long form question answering based on a broad topic, only having a subset of documents that actually talk about a very limited amount of topics might be an issue. So this is where we talk about diversity ranker, which simply introduces higher diversity in the order of documents that we introduce to large language models. So I think this might be an interesting topic to discuss. And then finally, another thing that is quite new to me is lost in the middle. This is a paper, I've linked it down below, but what it effectively tells us is that actually large language models really focus on what they see at the beginning and the end of context windows. So what do we do in scenarios where we might lose a lot of valuable context and information that simply happen to be more in the middle of the context window? So we are now looking into re-ranking techniques that will allow us to shuffle those up so that we lose as little relevant information as possible. And that's it from me. And I think these would be some of the topics that I'd really like to discuss in the panel session. And hopefully I didn't go over 5 minutes.
Sweet, no worries. Thanks, Tuana, for your time. And next up is Max from sid.ai. And if you want to share some slides.
Yes, let me quickly set up the screen sharing here. There we go. Give me a second. Here we are. Okay. Hi, good morning. Yeah, I'm Max. I'm the CEO of sid.ai. We're in YC's current summer batch. And I'll quickly talk about our experience with RAG and trying to get this to work in production. And the subtitle of this, the B story, is 11 months of pain. And quickly, I think this was covered already, so I'll jump over it quickly. We started building LLM apps for consumers quite early, but they kept failing. And the failure always looked something like this. I'd ask it to write a slogan for my company, SID, and OpenAI would think SID stands for sudden infant death syndrome, which it doesn't. And the easy and the quick answer is LLMs are a bit like first day interns. They're super smart and eager, but they know nothing about the person or company that they're working for. And the solution seems quite simple. You just add data. And I think, like, especially coming in with the classical engineering mindset, the feeling is, how hard can it be? I'll just take some documents, I'll chunk them into fixed length chunks. I'll then use an embedder. I can use OpenAI's, or I can use something else. I'll throw it into a vector database. And at the end, I'll create an internal or an external API endpoint to actually get this to work. But once you go into production, you realize that there's a lot more that can go wrong and that will go wrong. How do you handle changes to documents? If you're pulling from a live source like Google, Google Drive, Google Gmail, Notion, or any of these others, how do you handle those updates? How do you reflect those in the vectors that you have stored? And if you have something that's public on the web, and especially if you ingest from Google Drive, someone will ingest or try to ingest a 3 GB PDF and will send you an email at 2 in the morning if that's somehow failed. And I think one of the classical problems and one of the approaches that we'll get into a bit more later is, at some point you have a lot of chunks and every single retrieval result seems really, really bad, because you somehow have a finite set of granularity, but you have an almost infinite set of data. And then you have to somehow think about cross-encoders and re-rankers to bring that back up and improve that again. And then you have to think about things like markdowns, data distribution being different than, for example, PowerPoint slides like these, just because it's a different writing style. And if you want it to be represented well in the same latent space, then you're going to struggle. Then there's, of course, the compliance question. As soon as you're going more into the enterprise world, can I even use OpenAI, or do I have to self-host everything? And the complexities that come with LLM hosting. And then there's emails are a very, very tricky individual one. And I think I'll get into like some approaches that we've used for that later. Because there is so much information and just so much fluff and just so little information. And then there's things like Google's API CASA certification and processes like these that you actually have to run into before you can get up and running. And I'll quickly get into these two more. And one approach that we found worked well for us there. And that's, you have a limited amount of floating points, a limited amount of precision in your embeddings. And it's really important to make them count. So in the classical email sense, most of it is looking forward, great to hear from you, let's circle back, et cetera, and not actual information. And not actual information on the content. So what we have done, is we've tried to reduce the fluff, the niceties, and the writing style as much as possible. And to do that, we actually have a fine-tuned summarizer that just is designed to summarize email threads. And then we have an embedder fine-tuned on these summaries to actually afford us a larger degree of separation in the latent space. So instead of going through the original text, which is very fluffy and very and not that easily separable, we create this different kind of latent space just on the summaries, and that makes search much, much better, and means we need less cross-encoding and re-ranking at the other end to make it work. And yeah, that pretty much brings us to the end. The retrieval architecture depends mostly on the data type more than the usage type, and there's a long road from prototype to production. Thank you very much.
Awesome. Thanks, Max. And last but not least, Bob from Weaviate.
Hey, well, thanks for having me, Jerry, and the wonderful decks that I just saw. I'm not going to show a deck. I'm actually going to show a demo. So I'm going to bring this together and actually demo this live for you based on Weaviate. So let me quickly share my screen. One sec. Here we go. Screen share. Here we go. So let me give you a little bit of context what you're about to look at, and that's the this is the Weaviate console. Weaviate is a vector database, an open source vector database for those who do not know. So at some of the slides, you saw the term vector database mentioned. And basically what Weaviate takes care of is storing these embeddings and storing the data objects. So that could be the emails that Max just showed, or the examples of the meetups that Tuana just showed. In this case, I have a demo data set that one of my colleagues, Connor, made this data set, and he wrote a very nice blog post about it. So I can share that afterwards. But basically, what we're going to do is we're going to real time try to do that the RAG thing, and we're not only going to do that, but we're also going to do something new on top of that, what we call generative feedback loops in the data. So I've prepared stuff a little bit. So, and the query language that I'm going to use is GraphQL, but if you interact with it, you can use Python, JavaScript in the client, whatever you want. But I think this is an easy query language for everybody to read and understand what's happening here. So we have in the database, we have a query language, and we have the listings in this database. And what these listings contain are Airbnb listings. So here you see like the you see here the name of the listing, the neighborhood, the price per night, room type, and those kind of things. But one of the things that you might notice is that there's no description. So if you now want to search, if you do want to do semantic search or hybrid search, as Tuana mentioned, over these listings, we can, because we don't have any descriptions. So one of the things that we can do is that we can use a form of RAG to create a generative feedback loop. And what we're basically going to do is that we're going to, and I show that in a bit, we're going to inject this data into a prompt. And what comes out of the prompt will be stored in the database. So we have a little prompt here, and I have that in a notebook, right? So write a short Airbnb description for the listing, et cetera, et cetera. So, so I'm now hitting run. So basically we're using, for this demo, I'm using OpenAI embeddings. And what it's basically doing is that it's querying to Weaviate, and it's okay, show me all the listings where there's no description, take that information from the description, and it will generate not only a description for it, but also generate a vector embedding for it. So if I'm not sure if it's done yet, so running, because it's almost done. So if I now run it, so you see already, you see a few. So now you see the same listing. So this was the listing that we just saw, but now it has a description. And what we've done is by importing it, we told it we want to create a vector embedding for the description. So if we limit that to the first, let's limit that to the first one. So just to the first result. So that's this one. We can do this additional vector. So this is basically the vector embedding that in this case we received from OpenAI all the way down for this listing. So now one of the things that we can do based on the data that was generated on the information from the listing is that we can do a hybrid search, for example. So we say place in New York to walk my dog. So what this is going to do when I hit a search is that it's going to create a vector embedding for this query. It's going to do a hybrid search. Thank you, Tuana, for the inspiration. Let's go for hybrid search. And what it's going to do is that it's going to do a vector-based search on the query. And it's going to do a BM25 search, so on the individual words in the query simultaneously. And now the cool thing is that we try to retrieve a data object based on the description that was just generated using a form of RAG, right? So here we go, and run this query. And then it says description no. It's of course a demo. Why is it saying no? Let's see. Let's see, here we go for 2. Oh, here you go. So yeah, so here you go. So here it returns this result, so this description. I don't know why I didn't give a description to this one, but live demo. So basically what you see here is that it says, okay, welcome to Laura's spacious studio loft located in Central Park, etc., etc., etc. And now we can do RAG on top of that again. So we can say, let's say, we can say, generate single result, and I can give it another single result. I can give it another prompt, and I can say why is this listing a good place to walk my dog? And what I'm going to do is I'm basically going to inject the description. So what this is going to do is that it's going to query the database. So it's going to create a vector embedding for this result. It's going to return the description, the host name, the name, neighborhood, what have you. And then we're going to do rec again for the generated content, which is this. And we're going to basically ask it like if it can explain why that's actually a good result. So well, this one takes a little bit longer because we need to send 2 results to the API. But now you see here we have that result. So that we generate welcome to Laura Spacious Studio Loft out Central Park, blah, blah, blah. And then the rec result says like this listing is a good place to walk your dog because it's located near Central Park in East Harlem. And the nice thing that you can do with these kind of things is that you basically have seen 2 concepts here. So one is just pure rec. So that's this, where we basically are injecting that information in the prompt. And you can do that, doesn't matter how big your data set is. That is like kind of the power of vector databases. I mean, this data set has like 25 data objects or something. But you can, we see users that go literally into the billions. So you can quickly search for them. And then the second thing you can do with that is that you can actually generate content like this one and store that back in the database with a vector embedding. So now you can not only use rec for better search, but you can also use rec to create data in your data set, modify data in your data set, sometimes even delete data. So that was my demo.
Amazing. Thanks all for the amazing presentations. And with that, let's get into the fun part. Let's get into the panel. So I'll ask some basic questions to kick us off, and probably we'll do this for the next like 25 minutes or so. And then if there's any questions from the audience, please just feel free to chime in, and I'll probably just like interleave some of the questions along with some of the basic questions I prepped as well. Let's kick it off with a kind of like introductory question, which is, so a lot of users have built these types of retrieval augmented systems, or I'm going to call it RAG for short, in the prototyping phase. In your minds, what are the key considerations that users would need to take into account when actually trying to build RAG in production? So everything from performance, cost, latency, scalability, security. And we can start with Tuana.
So the way I see it, there's actually 2 parts where a lot of considerations go into, kind of separately from each other, because there's a retrieval step of the retrieval augmented generation pipeline, and then there's a generation step. So in the retrieval step, you have to consider your retrieval models, but this can actually be quite relatively small and cheap in some ways. They tend to be a lot more lightweight, whereas in the generation part, I see tons of considerations. I live in the EU. It can even start from considering security-wise what kind of models you want to use. We see this very often here in Europe. For example, OpenAI models are very, very performant, but sometimes it's just not an option given the legal circumstances. And then you have to consider whether you are going with an open source model and whether you're hosting it yourself, or you go for a hosted service such as Azure or SageMaker. This alongside it brings, of course, cost considerations as well, and so on and so on. And then the second part that I briefly mentioned with hybrid retrieval, I think, it kind of depends, it goes into a bit of latency considerations. And this is really dependent on your use case, I would say. For some people, simple embedding retrieval with a very lightweight model. If you're lucky enough to have a sentence similarity model that works on your language, maybe this is fine. But like actually Bob's example with New York was a really good one, where you need to combine both keyword search and embedding search. You are doing 2 things basically at once, although keyword search can be very, very, very fast. You now have 2 things to think about that run in parallel. So there's some latency considerations. Those are the main facets that my mind goes to.
Thanks, Max.
Yeah, I think the main part, or what in our experience ends up eating a lot of the time, is actually getting the data syncing part right. And that is just because the APIs for the services are so different, and depending on how you ingest information, you actually have to keep quite a complex state of what you already have and what you still need to add or need to remove or change or modify. And that can just, out of experience, eat up a lot of your time. I think for a lot of the stuff here, you have to be quite conscious of how much data you actually want to ingest and what the search sample size is. If it's quite small, then probably you're well served by an easy solution and you won't run into that many issues. But as soon as you're probably looking at a few million chunks, you're going to have to get more creative, and hybrid search is a great way to actually get there. Yeah. Also with OpenAI, I think like the legal considerations are one, and the other is just speed, right? By self-hosting these models and by co-locating them with your vector database and the other things, you can actually get much, much faster, right? And have turnaround times in the, high tens of milliseconds or low hundreds of milliseconds for the entire part, including hybrid search. And if you try something like that with OpenAI's embeddings, you're oftentimes looking at a P99 of above a second.
And Bob.
Yeah. So what's interesting is, and to build on top of Max's point, is that there's like this big distinction between a demo, like I just gave, right? So I mean, I had 25 data objects, and the example that I have read that took about 25 seconds to actually execute. That is for demo, great, right? That's not so great if you have a real-time use case and you have like 100 million or more data objects, because then it's going to take quite some time to index all that stuff. So the combination of these production systems of how you work with these models is completely different than these examples that I just gave. So I agree with what everybody said there. So what's super interesting to see from my perspective is actually development when it comes to CPU-based inference, because the thing is, at some point you need to make like a cost. You need to make estimations about cost. So again, the example I just gave was perfectly fine for this demo. Is it's going to be very expensive in production, right? So it's like we have a user that has like 20 billion data objects in Weaviate. Even if they wanted to use, for example, OpenAI, that's $2 million to create vector embeddings. So then an open source model is way more interesting, how you operate that, etc. The good news is that there's so much work happening in like that stack. So like the database with the models and those kind of things. And secondly, also something that I find very interesting, and that goes for that Jerry, were you working on, but also you, Max, and Tuana. So the tooling that starts to arrive around the ecosystem, basically the solutions to help people actually, figure out how to store the information, how to generate the information. So long story short, I think what I'm very excited about is how these things basically and now are starting to come together. And one more idea that I want to add, just more for people that are listening here, is that I think, if I have to make a prediction, is that we're gonna see this combination of not only doing RAG for search results. So as I just gave the example of like why is this a good place to walk your dog, but you also that we're gonna say like, is this a good representation for my data set? Right. So the example that Max just gave, if you have all these emails stored and it just says like, oh yeah, thanks for the info, that then actually the model can say, no, this is way too generic. And that we start to use RAG and so the models in the database and the tooling to achieve that, to actually clean up the data and actually make sense of it. And you can go very far with this. So if you, for example, look at if I may, Max, use your example, that you can even say, okay, this email is not containing enough information in vector space. Let's go to the previous email and see what was in the previous email, and then generate content based on that. So I think that's something we will see in the near future too, that people also start to use the models to query the data and then modify the data set. And there's like a harmony of the models, the vector database and the tooling like you all are creating. So I'm excited about that.
Yeah, there's like one thing that we're also exploring is the notion of something like lazy information retrieval. So if someone asks a question, right, or if there's a query and there's no really good answers by whatever metric we find, right, that we can actually go in and try to collect more and more information, have intermediate synthesis steps to actually find an answer for that question or for that query once it comes again, right? And trying to actually, like, in an intermediate step, find more information and collect more, something that wouldn't work at query time, but that we can do in kind of like more the static kind of regime.
Interesting. So like dynamic information lookups, basically. Sweet. That this is awesome. And maybe the next thing that we should talk about is let's talk about data. So everything from, you know, ETL extraction, transformation, loading into a vector store. This is a pretty common step that users face when they first build a RAG system, from loading data, let's say a PDF, chunking it up, putting it into a vector store. And Max and Bob, both of you have talked about some of the key considerations you need to think around the data. So around performance, around costs, around latency and scalability. What are some of the key pitfalls that users commonly run into if we, you know, drill down into this a little bit more? And what are the key considerations that they might have to experiment with? So for instance, everything from like chunking strategy, like document transformations, how do they account for scalability? Maybe we could start with Max.
Sorry, I didn't, my internet connection was bad. I didn't catch the last 20 seconds.
Okay, no worries. The high level idea is just what are the key pitfalls that users commonly run into in kind of this data ETL layer? And, you know, you were talking about this in some of your slides as well as your answer too, like everything from chunk sizes to scalability. And curious to get your thoughts on, yeah, like how should they robustify their data to create better RAG systems?
Yeah, I think that there's the one part which is just follow the standard practices around you're effectively handling untrusted text. So there's always stuff that can go wrong and will go wrong, and then setting reasonable limits. So for example, right on, I think in our production, you know, someone tried to link, you know, a few terabyte large Google Drive, right? And you need to make sure that actually the pipeline is engineered to handle something like that, to batch it properly and then return, and not just, you know, return an out of memory error and break the entire system. And especially if you're offering this to multiple also disjoint users, you have to think about how do you actually, right, provide some sort of exclusion that, you know, one person can't break the service for everyone else. I think the most difficult part to engineer from that perspective, apart from, of course, the retrieval pipeline, is exactly the data syncing component and making sure that works well. And then, you know, handling all of those keys and actually all of those API access tokens. I'm not sure how many of you have actually tried, but for example, getting also API access to Google's Drive API and email API is a huge process and very, very lengthy. And it's like a 600 emails front and back and forth with Google to actually get permission to do that. And then, you know, having a CASA assessment and et cetera, that you have to run into. And I think like these are definitely the underrated challenges and stuff that, you know, you look at and you're like, yeah, this sounds kind of reasonable, but, you know, then you go about it and you actually realize, hey, this is actually a lot of work.
So, Bob, did you have follow-up thoughts?
Yeah, certainly. So so one of the things that we see a lot is that, and I'm going to assume that a lot of people on the Zoom here are just, you know, are building something or playing around with something. And again, like my example with 25 data objects, you know, that's fine. Even if you think it's pretty fast, that you've optimized it, and you get to maybe like, and in your mind is like 200 milliseconds is great. That maybe. If you don't have a large data set, right, then it's unworkable with 200 milliseconds. So what I would recommend people do is that if you take just a sheet of paper or like a whiteboard, and you just from the moment of ingestion all the way to the query, you just draw out what's happening there. How long was inference time on the model? How long was retrieval time based on database, et cetera, et cetera. Then you get to a number. So let's say that that if you, in my case, that I use these OpenAI endpoints, that I get to maybe 150, 200 milliseconds. Just do that times the number of data objects that you have, and then you will be quickly shocked about the the number that's there. So you really need to start to think from the perspective of a performance if you're really building a business now, or whatever you're building as if it has like a large data set. What I recommend doing is that, for example, if you use an open source model or a model that's in SageMaker or those kind of things, validate if that model generates the results that you want. And if that's a check in the box, build the pipeline as easy as you can, perfectly fine to do it like with the latency from OpenAI, etc. And start to optimize for them one by one. Just take the building block out, replace it with something else, and just start to minimize the time. If what we know from the big production use cases where we have, where retrieval from the database, embedding generation, etc., plays a role, if you really optimize it well for big data sets, you should be able to get between like 20 and 30 milliseconds today end to end, if you do that very well. But it's a profession, right? So it's like people are really good at just optimizing these kind of things, but just keep it in mind, because I've seen a lot of people enthusiastically build amazing prototypes, and then they said like, but now to make this into a valuable business, we need to do this, you know, X 100 million, and then they were shocked with the infrastructure and embedding prices and times that were associated with that. So shouldn't hold you back, but just bear in mind that these things take time. What people might like to know if they're new to this is like, a lot of work is already being done there. So for example, in Weaviate, we have like a Spark connector that people literally pump in millions of embeddings and data objects per minute. So these tools are there, but make sure to think about it. And if you really have like a data science background, I would highly recommend to start to think also about the DevOps side or the engineering side of just bringing this stuff to production.
Great. Tuana, was there anything you want to add?
I can add some things in this data ingestion part based on what I see from our community, which I think probably actually, Max, with your product, you also experienced a lot, is especially if you want your RAG pipeline to be sort of up to date to your time. There are actually two types of data sets that you do RAG on. There are some cases where you have a data set that is not necessarily going to change that much. So you don't have to think about data ingestion more than once, maybe. But there are some other cases where I'm sure in these examples, or for example, you want to be able to do continuous RAG on emails that are constantly changing, or Notion pages that are constantly changing. That requires a completely different architectural setup, maybe the same pipeline, but a completely different setup for scalability. So this is one of the main considerations I see when we're talking about data ingestion for vector databases.
Thanks for your thoughts. I think this is a related question to data, and we'll tie into the next section on kind of retrieval as well. And it's actually a question from the audience. What is the best way to chunk your data? And how do you think about optimal chunk sizes as well as chunking strategies? I think we could start with Tuana, if you want to go first.
I find this question quite difficult because it feels like a lot of the case it can be trial and error, but it also is going to depend on the embedding model that you want to that you decide you want to use. So a lot of embedding models actually, if you do want to do retrieval with a given embedding model, you're not going to go beyond a certain number of words for your chunk sizes. But at the end of the day, there's also chunking strategy. So for example, I'm going to show it with my hands because I can't really describe it any other way. But for example, we have this two paragraphs following each other. And there's this chunk and there's this chunk immediately after it. But they have potentially something here just at the end of it would have been relevant to the sentence that started right here. So we see a lot of people trying around with chunks that actually overlap each other so that you don't lose context that might be relevant given a scenario where one chunk is retrieved and the other is not. So there's a lot of pre-processing thought that goes into chunking. There's obviously the sizes of the chunks that matter. And of course, I'm going to go back to this, but I think chunk sizes probably is going to be something we discuss more if it does turn out that diversity is going to be very important for LFQA, because then we have a limited amount of context length we can fill, so a limited number of chunks we can add into our context. So if you want to include a lot more diversity, maybe smaller chunks are better. It depends on the type of data you're doing RAG on. That's my overall answer.
Bob, did you want to add a response?
And so this is a question that I don't have a good answer on, because the thing is, like, the moment that it hits the database, it's already chunked. So it's so as you, Tuana, and you, Jerry, that's like, of course, your expertise, like in the tools you're building, how that's done. But so I'm not sure if I'm allowed to break the format a little bit here, but I would love to hear your answer to that question, Jerry. So because you see that stuff a lot, of course.
Oh wow, yeah, I thought I was interviewing you guys. So I mean, I think it's basically what Tuana mentioned, and I was actually kind of curious to learn some of the tips and tricks that you guys had, because I was going to see if I could implement some of this in the framework itself. The two things that I typically see is, in terms of chunks, I think smaller chunks tend to lead to better embedding-based retrieval, just because you're not like averaging out the relevant context with like a bunch of random stuff like before and after the actual piece of text. However, the downside with smaller chunks actually is the fact that when you actually feed this to the language model for synthesis, it doesn't actually have enough context to really give you a detailed answer to the question. And then I think the other piece here is a lot of people, especially pretty much everybody building LLM maps for a specific vertical on specific types of data, builds their own custom parsers as opposed to using like any of the out-of-the-box parsers from, for instance, like LlamaIndex or LangChain. But yeah, actually, Max, I was curious to get your thoughts on this too, because you also talked a little bit about this in the slides too.
Yeah, I think I mainly have 2 points. So first of all, I think you have to separate the chunk size at embedding time and the chunk size at retrieval time, because these can actually be different, right? And this is also how we approach it, right? So sometimes, right, we'll retrieve actually quite small, something that's, you know, inside the distribution of the models that we use for embedding. And then we'll actually try to retrieve the previous and the post chunks, right, to actually provide more context, as you said, for the query, right? So these are sometimes two different things. And depending on what you're working on, actually splitting the chunk size at embedding and the chunk size at retrieval makes sense. So I think like that's the first consideration. And then in the slides, right, the other one is you can quite freely choose to actually search and retrieve over a different latent space than just the raw text. And for us, for emails, that was the summary space. So we have a quantized MPT7 bill fine-tuned on email summarization. And all that model does is it'll take in a thread and it'll try to output a quite fixed size summary of that text. And then we have an embedder that will actually then an embedder that is fine-tuned to just those summaries, and that will then go around and find it. And that usually means we lose a lot of the context on the writing style and, you know, the kinds of those components. But if you're building a RAG for information retrieval and not for style retrieval, that is actually what you want, right? And you have the ability to engineer it that way and do it that way. And then, yeah, I think like more generally, right, to then measure the end-to-end performance. You know, I come more from the research background, so I love thinking of, you know, synthetic benchmarks and like ideas to test this, et cetera, et cetera. But the most important thing is to capture that quality from your users, and then try to evaluate different approaches in your pipeline that way.
Yeah, and if I may quickly add something, because something popped into my mind that I actually do have a response to this. Again, thanks, Max, based on what you said. So from the database perspective, that's kind of where we sit, right? So the demo that I just gave you, you see me do in this case, hybrid search, but it could also be the vector search. But the thing that you also have are filters. So the thing is that you set the complete, you load all the data in the database. So let's say that we take these emails, and let's say that we have like 100 million emails, but you know that you're searching for an answer based on something that's in a email thread, for example. You can actually store it in a database. So you can say, okay, this is the body of the email. This is the vector embedding of the body of that email. And that is that's coming from this email address, and it was part of this thread. So then your database query looks like something like, do a vector search for something, well, very specific, but only limited to that email thread in those 100 million emails. And that works very well. So as a tip, I guess, bear in mind that you don't have to solve it 100% on ingestion time. In this case, in the database, you can also be smart about how you're structuring the data that you're storing, and then build filters on top of the vector search that you're doing. So that's also an option.
I actually wanted to add something here, because actually the conversation on chunks and then what Max said made me think of one part of RAG that maybe we didn't necessarily discuss, but it could potentially have an effect on the type of chunking you decide to do, is that RAG can mean many things, actually, based on simply the prompt you provided. So initially, what is even your task? Why are you building RAG? I think often we talk about question answering, but for example, in Max's example, it could be summarizing emails, which are very short. In another example, it could be to summarize something about a whole topic. And then you have your retriever set to retrieve maybe the top few most relevant documents out of your database. So this is actually a good consideration on whether your chunks should be larger or smaller, because if you, for example, are asking it to summarize a whole topic, maybe a larger size of context and less documents being embedded into your prompt make more sense. So actually, I think the point of your RAG pipeline matters a lot in how you design your chunking as well. Yeah,
that's a good point. And that is like one more idea to add to that, just for people playing around with this, is like what you can even do is that, and sorry again from the perspective of the database, but that's what I do every day. So that's where I live. You can even say like, hey, we have email threads and we have a summarization. So we use RAG to create a summarization of the whole email thread. We store that. And then the individual emails. So then you basically have two queries. So query number one is like, show me the email that was about X. And then when you've retrieved that email and you have the ID, for example, of the email thread, you can now search through these individual email threads, set a filter for the email thread, and drill down into the email. So let's say that you have an email with 10 threads. You basically have 11 data objects. So one data object with a summarization of the whole email, and 10 data objects with embeddings that are the individual bodies of the email that you've stored. So you can get very smart about this kind of stuff, and just be based on your use case. You know, you can do a lot on, as Tuana said, like using RAG to generate that kind of stuff, but also store it and retrieve it in a smart way. And then that combination that brings you very far.
Awesome. Thanks everyone for the thoughts. I do actually want to talk a little bit about retrieval, and this leads into some of the later conversations around like how to structure the data, and also like, you know, adding metadata filters, and also hybrid search and re-ranking. Yeah, like what in your minds are just generally the top retrieval issues that users run into when they maybe first build RAG with, for instance, like top K embedding search, and how exactly do things like hybrid search, re-ranking, adding metadata filters help with that? And Tuana, if you want to get started.
So off the top of my head, actually, this is not a problem with retrieval, but potentially a problem with the way we view RAG or evaluate RAG. And that's the first thing that pops to my mind when you say retrieval is often I feel like we seem to overlook the retrieval step when we think about the performance of an entire RAG pipeline. Someone asked that in the chat and I replied to this, and often we see the result of a RAG pipeline and the mind goes straight to the large language model we're using, rather than seeing, actually, let's drill down, like Bob said earlier, let's drill down. Is my retrieval step actually performing well? Am I getting the relevant context to begin with? And then obviously this is an issue at this point with the retrieval methodology you decide to use. And one of the reasons I brought up hybrid search, and I saw that there was some chat going on in there, is for example, again, to reference what Bob and Max brought up, let's imagine a scenario where we have emails and we need to be allowing our users to ask what was the topic of email ID something, or let's assume we sell shoes and we've got a specific shoe name or ID and say, what are the specifications of shoe XYZ? And unfortunately, embedding retrieval that we really often use for RAG, and we stop there, often is not great at retrieving these types of queries. They're not great at doing keyword search, but we still want to be able to do semantic search to get a more comprehensive answer as well. So this is where we see people use a combination of keyword and embedding search, basically what Bob was showing in this demo at the beginning. And when we talk about metadata filtering, I actually posted this in the chat as well. I'd love to hear what you guys' experiences have been. But for example, addition of metadata within the context you provide to your RAG pipeline is something I do very often, maybe even misuse. But this allows us to provide some sort of labeling information of each of the documents we retrieve and provide extra content or context with our replies with our large language models. I, for example, have used this to add, if I've got a website I've crawled, or I've got a set of websites I've crawled somewhere in a static data set, I tend to have the URL in the metadata. And I love this for documentation search, because then if I have the URL of that piece of documentation I retrieved right after it, then the reply of a large language model can simply reference the actual place that the answer was generated from. And in use cases like this, I see metadata very, very useful, but I'd love to hear you guys' thoughts as well.
Yeah, so if
Oh, sorry, Bob,
sorry,
go for it.
Oh, yeah, no, so I that's a very good point, Tuana. So three things that I want to respond to. So the first one is a lot of people ask questions about like what we call like explainable AI, and using the metadata in these results is actually very helpful, because what you basically can do is you can say, well, let's go back to the example of the emails now on that topic, that you basically can say that whatever you're generating with the generative model, that you can say, okay, and that came from this, and the metadata is that you give might, for example, be the email thread ID, and you say, okay, so it's coming from that email that was sent on that date, for example. So you know that allows you to make it explainable and give that kind of context. The second thing of usage is like the example that I basically gave from with the Airbnb data set, that actually that listing information is a form of metadata. So we just call it the data object, but it's a form of metadata. So you use the metadata to generate the content that you create an embedding for to search over, right? So that's also something you could do. So think about use cases, as in staying with the emails, is that the email body is a form of metadata. You can basically, okay, what should be the right response to this email, right? And then that's what you store. And the third thing that I wanted to say, and this is something that, because Tuana already mentioned this, but we see this coming back more and more often, that indeed pure vector search, pure vector-based retrieval is often not enough for your case. And I'm sharing now a link to a visual in a blog post in the chat window. And one way that we explain that internally often is that, like, if you have a big sea with fish and you want to, catch a specific type of fish, then you throw in the net, and the net is basically your vector search. So in space where to search, but then net comes out of the water, and it does not mean that the first thing that you pick out of the net is actually the fish that you were trying to catch, right? So what the re-ranker basically does is that it organizes these results, and it has to do a little bit with traditional keyword-based search, or how we used to do those types of search results. Because if you, for example, take an e-commerce solution, you might say, well, I might search for Adidas shoes for the summer, but the results I want to see first are shoes that are sold the most, right? And otherwise, you just have like random. I mean, what you catch from your data set, what you retrieve, contains probably the right information, but now you're stuck with 20 shoes, and maybe nobody's buying these shoes, right? So it's like, and then you want to organize based on that. So bear in mind that re-ranking does not always has to be based on a model. Re-ranking can also be, I do a vector search for Adidas shoes for the summer, and I want to re-rank them based on shoes that are sold the most. So that's also a form of re-ranking. So what you basically do in the re-rank step is that you retrieve that set, but then you somehow need to organize them in a way that for your user who is, being presented with that information, they see the right stuff first. Not in all use cases that's needed. Sometimes you just want 20 results and you don't care where they are in the order because you need these 20 results. But for example, an e-commerce application, then you might want to have that.
Awesome. Max.
Yeah, not that much. Like, I think in principle, if you're building something with like the toy data set that Bob showed, then really nothing matters, right? You don't really have to do anything. But if you're building something larger, then usually the answer is everything kind of matters, right? So yes, you have to use the metadata, and oftentimes from a pure customer perspective, you need to be able to do keyword search. If I'm explicitly giving you a keyword or the name of a file or the name of something that I want the context to be about, and it doesn't find that result, that usually leads to incredibly frustrated users. I think like you're going to have to run into these things. And then, yeah, there's definitely also a good chunk of engineering that has to happen. Cross-encoders, re-rankers are definitely a big part of that. I love the idea of also doing the metadata re-ranking at the very end. I think, well, it's definitely one of the takeaways from me from this. Yeah, so I think not that much to add that from that perspective for me. One thing maybe Tuana, I think, got into this in the chat is recency. And that is also really big. Again, depends on like what kind of data you have. And it also really depends on just the kind of data you have. So for example, let's get back to email. Actually, I see that's the common thread here. But if we email every 6 months, then an email from 6 months ago can still be quite up to date and probably should still be ranked quite highly if that's something that I'm asking you explicitly about. But if we email every single day, probably an email from last week can already be outdated, right? So you actually end up having quite complicated different kinds of ways of accounting for that and for accounting that recency. And it's not just, a logarithmic curve over time. But it's actually something a bit more complicated if you want it for a production system, which is why we're here.
Sweet. This has been an awesome discussion. I think we need like an entire separate discussion on like an entire separate webinar on RAG observability and evaluation. I know a lot of you in the chat were asking about that, and I think that deserves like another hour at least to fully chat about. I think all of you made some great points, and I learned a lot personally myself during this webinar. As we wrap up, maybe we could just go through each person and in 10 seconds, just give your hot take, just any hot take on RAG, or, if you don't have a hot take, just talk about like what's kind of top of mind for you in terms of problems that you're trying to solve, and just wrap up there. And we can start with Max. I'll just put you on the spot.
I'll start off with the hot take. I think it's something that that Bob also brought up before, but that just pure vector databases and embeddings almost never work for production size data sets, right? That the approach is always more complicated, more varied, and actually has to be very, very finely tuned to the data that you're ingesting and the use case that you want to use, but especially the data you're ingesting.
Bob.
And so I think a hot take in 10 seconds. So my hot take is that I think that this paradigm shift of like the database and the data set interacting with itself, that's in like a couple of years from now, everybody's doing that. And we're like, why didn't we ever do that? So I think, and that RAG is a core thing of that. So I think that these growing, manipulating data sets, I think that's the future.
And Tuana.
Am I allowed a hot take on something we didn't get into at all today, but I
Yeah,
think
go for
is
it.
relevant to RAG? Is I often see when we talk about RAG, we talk about the models, and my hot take is models in isolation to the prompt, and the prompt in isolation to the model that we send the prompt to. Evaluating them both separately is not evaluating RAG properly. I think the combination of the instruction you decide to send and the model you decide to use with it is probably one of the most important components of a successful RAG pipeline.
Okay, awesome. Well, thanks everybody for your time. Thank you especially to Bob, Max, and Tuana for your time joining us here today. We'll be continuing discussions. We'll have follow-up webinars hosted by LlamaIndex on kind of talking about more components of RAG, especially around stuff like observability, evaluation, and maybe just a part 2 on a lot of these like data decisions as well. Join us follow us on Twitter, join us on our Discord. We'll be continuing the discussions and thoughts there as well. All right, thanks everybody.
Yeah. And thank you, Jerry, for putting this together and coming
Yes.
up with a great set of questions. It was a lot of fun for us.
Glad to hear.
Thank you.
All right,
Bye.
take care, guys. Bye.
Thank you.